And first of all, welcome. This today is about our Closing the Care Gap for World Cancer Day. But just to update you, last time we met was in October when we had a great session about advocacy in radiotherapy. And this in some way moves on from that. And the action point from last time was to develop an advocacy toolkit, which we'll talk about at the end of this meeting, because we have made progress with that, which is really exciting. So today, as of World Cancer Day last week, along the theme of closing the cancer care gap is really what we can do with radiotherapy. And as we've been meeting with this GCR over the last couple of years, it's really the situation we're in. We're in the middle of, and hopefully coming to the end, near the end of, in sight of COVID, with all the challenges that has thrown up both now and for the future, but also all those opportunities with radiotherapy. We still get back to the point that radiotherapy is needed in 50% of cancer patients and in 40% of cures, and there is not enough radiotherapy either accessed or delivered around the world. And for Mary's and others' papers in 2015 showing very clearly that if we just increase access to good radiotherapy, you can save 1 million lives. And if you could find a drug that could save 1 million lives, people would buy it. So we have to do more to improve access and capacity. And from the other discussions we've had last year, also implementation science, not just buy a machine, but make sure we're using it correctly, make sure we're measuring what we're doing and measuring those outcomes for that. And so what we're going to do today is to have a roundtable on where technology, both now and in the near future, can really help us now close that care gap. So we want to think outside the box here and really think, what is it going to look like, and how can we actually make these things happen, be a bit disruptive, be a bit thinking. And we hope to get at the end of this too, with people on board, to write a white paper about where are those opportunities and how do we do things differently to make sure we're using that technology in the best way, and to see all those things. So really we can have our visionary hats on here. So we've got two speakers today that's going to help us stimulate that discussion. Pleasure to invite, first of all, Steve Laws, who's Vice President of Advanced Oncology Solutions in the EMEA for Varian. And he's had a lot of experience from software engineering to clinical solutions in sales, etc., and services and sales. And he's traveled a lot and seen a lot of clinical developments and technology adaptations and patient access. So he's going to talk to us his thoughts on how we can really do this differently and move forward so that we access and use all this technology. So Steve, perhaps I could throw the things open to you now. Thank you. Thank you for coming.
Yeah, sure. It's a pleasure, Pat, and yeah, thank you for the opportunity to share a few thoughts from industry. And as you said, the intent really here is to get the conversation going, to get you thinking, maybe provoke a few thoughts. So when we come to our discussion, we can do that. We can do that together. So we can go to the next slide. You know, as you just said, Pat, you're absolutely right. We know that the gap in care is there within cancer care globally. What's also interesting is that, in fact, the gap is actually growing faster than the world's ability to develop and address patient needs. So it's a gap today, and right now, if we apply a status quo approach, if we don't do anything differently, effectively that gap is likely to only get larger as we go forwards. You know, moreover, as care improves, patients are thankfully living longer, which is a fantastic thing, thanks to some of the great technology and treatments available. But that means that we need to ensure that we're equipped to provide even more ongoing support into the future. So, you know, if we stay on our current trajectory, which is where we are today, you know, we might be able to reach half of all the patients in need by 2040. And as we all agree, you know, that's obviously nowhere near enough. And what we really want to do is to focus on helping get more patients through the system more efficiently with better treatment options going forward. So if we go to the next slide, you know, it's quite evident that technology isn't the only factor needed to help fill this gap. Technology is part of the problem and part of the solution, but there is a massive challenge with human resources as well. And it's very clear that we've got to look at doing things differently if we plan to have any shot at meeting this growing burden. If you look at this data that was published in the Lancet Oncology, that suggests that we would need an extra 3,000 oncology centers, 22,000 LINACs, but 150,000 more skilled clinicians by 2035. So that gives you some idea of the scale of the challenge. We in industry, Paul's here from Elekta. We can build more machines. We can certainly do that to fulfill that global equipment need. But we think it's important that we start to think differently about how to solve this problem, and particularly, as I just mentioned, the human capital gap in radiation oncology, as well as other areas, and equipment's obviously part of that. And I think, going forwards, and at the heart of that different thinking, one of our thoughts is really that we're going to need that combination of people, but also AI and technology and data in combination to the current technologies as we look to adapt into the future. So looking at the next slide, one of the things that we are very, very keen to do is to move increasingly over the long term into rather than what you might call more of a transactional relationship with industry, where we supply equipment over a period of time and we service it, and then we come back and replace it after a period of time, and so on and so forth. Our thinking is that really we should be partnering together much more closely along the life of a customer's use of a piece of equipment to address this almost four-dimensional puzzle together. Clearly clinical quality can never be a compromise, so that's a given in all of these. But at the same time, really working together on how can we use our technology as best as possible to drive, optimal operational efficiency and obviously resource management, which is a complicated way of saying essentially we want to do, more with less and be as efficient as we can be with all of the technology that we have. And I see that around the world, whether it be in developed economies, in developing economies. There's some tremendous technology and software out there and in the world today, but are we really using all of this technology to 100% of its capability? Probably not. And one of the things that we're really keen to do is to work much more closely with you as partners in a clinical environment to make sure that technology adoption is done as fully as possible, so you can benefit as best as possible from all these fantastic new tools that are becoming available, and not just look maybe at the tools within the bunker or within the physics department, but actually look holistically at the whole cancer operations and work together to say, how can we, with a combination of our people, of our software technology, and of our machines, really promote optimal efficiency within the department. So if we go to the next slide, I've got a few examples here about what that might look like. We know, for example, that the whole area of planning is a huge bottleneck, right? That's true pretty much everywhere I go. And by the planning process, I do mean also the contouring piece as well as the planning piece. There are some tremendous tools out there, certainly, on the contouring side around AI that can reduce, the contouring process by up to 80% of time, which is absolutely huge. And question to the audience, is it a good use of a clinician's time to spend hours on end, contouring tumors on a screen, right? I'm not suggesting, by the way, that you don't need the skill to make sure that those contours are correct, and you don't need the skill to make sure that the ultimate, clinical target volume and planning target volume is absolutely bang on. But the actual process of producing those contours, is it a good use of a clinician's time? If we can automate that through AI and produce an equivalent quality and consistent quality, would that be a technology that we should really be looking to adopt? Same on the planning, automation, and so many other tools that we're introducing now to speed up the process. And I use the illustration of a pilot. I was lucky enough very recently to go into the cockpit of an Airbus A380 And I said to the pilot, really simple question, how do you fly these things? These things are huge, right? A 500-ton aircraft, with thick end of 400, 500 passengers. And his answer was really interesting. He said, oh, we don't fly this Airbus. We just monitor systems, which is really interesting. So he was saying that as a pilot in the aviation industry, his role, the role of a pilot, doesn't resemble at all the role of a pilot perhaps 10, 15, 20 years ago, whereas now they're relying on technology for so many tasks to be automated, and then their role has evolved much more in terms of making sure that everything is working, that all the quality measures are met, et cetera, et cetera, et cetera. So, similar question, I guess, within the world of radiotherapy, are we reaching a point with new technology where perhaps we need to relook at how we adopt technology and how we evolve the roles within that context? Same with clinical efficiency, looking at standardization of processes, streamlined workflows, optimization of pathways, the ability to be paperless, to optimize communication between departments. Are we really making the very, very best of what we have today, or should we be looking at different ways of training people, for example, moving from a feature-based training approach to more of a process-based training approach, which is much more a partnership approach than a transactional training program, for example. Moving to the right, should we be discussing more collaborative efforts where perhaps with industry, rather than us being primarily suppliers of equipment and support services, are there services that you could look at doing together? So areas where there are bottlenecks such as treatment planning, quality assurance, physics resources, and then bring into the mix the whole area of IT, which would allow us potentially to centralize some other resources. So we can pull resource in specific places and make the very best use of it across multiple more disparate networks of radiotherapy centers. So these are some thoughts, but really the key message here is could we and should we be thinking in a more collaborative way of how together, from a resources point of view, looking at our customers' data and our customers' objectives, your objectives, combined with what we see in the market and all of our joint expertise, can we be smarter and faster and better at what we're doing today with the equipment and technology that we have? I think that was my last slide. I hope that's given you some food for thought. I'm going to pause there, and I think, shall I hand back to you, Pat?
Yes, no, thank you. That was,
and look forward to our dialogue.
Fantastic. Yes. So we thought we'd have the roundtable discussion at the end, but perhaps please use the chat box, because you'd probably all be thinking about things now we need to discuss. There was a lot in there. I'm loving the idea of monitoring systems. So the clinicians, all they have to do is add the little bits at the beginning, then there's monitoring the systems, and the treatment actually itself modifies toward the patient. Fantastic idea. So please use the chat box. Now let's hear from Paul, and then we can open up this discussion. So it's a pleasure to introduce Paul Naine, who is the Director of Clinical Operations at Elekta. Now, Paul used to be in high field MR and MR spectroscopy, so that's great. And he comes from a human technology interface, specifically in lower middle income countries. So he's going to share with us his thoughts about these issues of how do we disruptively move the dial a bit on this and be much more different in our thinking. So Paul, over to you.
Thanks, Pat, really appreciate it. I'm just going to do a quick test. Can you guys see my screen and hear me okay?
Yep.
Fantastic. I see captions are magically working now as well, so that's even better. All right. Well, good morning, guys. Thank you, or good afternoon or good evening, wherever you are. And I want to say thank you to GCR for the opportunity to share some thoughts today. Recognizing World Cancer Day, as you said, Pat, just a few days ago, I couldn't help but include this phrase because I thought it was just beautiful. Where you live shouldn't determine if you live. So with that, I wanted to kick off by talking about space. Now, I know you're probably thinking, I thought this was about access to radiation therapy, and it is. Accessibility to spaceflight has a lot in common with radiation therapy accessibility, in that it was a really complex technology which was quite inaccessible over 60 years ago, and now today it's quite accessible. So today, We're going to talk a little bit about what we can learn from the space industry and how it's made that complex technology more accessible, and how we can apply it to radiation therapy to make that more accessible. Excuse me. So let's start with a brief timeline of spaceflight. Back in 1961, Yuri Gagarin was the first human in space after receiving about 6 years of military training. It wasn't until 1984 that we saw the first human with no military background go into space, with Charles D. Walker flying in 1984. Fun fact, he was actually doing some pharmaceutical research that eventually led to some chemo drugs. Fast forward another few decades to 2021, so just last year, and we saw Haley Arsenault go into space with the Inspiration 4 crew after just 9 months of training. There's a really interesting Netflix documentary on the mission for those interested. And another fun fact, and linked to our field, is that Haley herself is a cancer survivor who went on to become a physician's assistant treating leukemia patients at St. Jude's. As you can see, the time taken for these guys to get the knowledge to fly decreased dramatically during these 60 years. So what changed? Of course, equipment simplicity increased dramatically. Here you can see the controls that Yuri Gagarin had in 1961, with very manual analog controls. You can even see that little globe in the top right-hand corner for navigation. Fast forward to 2021, and here you can see, excuse me, the 3 screens that are used to pilot the Dragon capsule. As you can see, much simpler, lots of automation, as Steve has spoken about. The products are getting simpler. Equipment simplicity, of course, has a lot to do with affordability and accessibility. But it's not just product simplicity that creates access to technology, as Steve has said. Knowledge on how to use technology is also important. The equation of access to care is very similar. We need to have products and the ability to use them to create access to care. If we focus the knowledge, if we focus on the knowledge component, looking at spaceflight, we can see 3 principles that guided the knowledge evolution. And today we're going to identify those principles and look at some examples in spaceflight and in radiation therapy, starting with number 1. Recalibrate what knowledge is needed. What knowledge do we need? Historically, as radiation therapy was in its early days, we tended to train a lot of theory and product-based information. Do we need to do that anymore? Or should we be training how to treat? We've often trained a lot of nice-to-know information versus need-to-know information. Is that the best way today of providing expedient access? And we've often thought we need to understand every possible permutation of treatment before starting any treatment. Today, is that a reasonable expectation? We've seen some activities to address and answer these questions. In space, for example, we no longer need the little globe in the top right or the knowledge of astrophysics to navigate like Yuri Gagarin did. We do need different information, however, like how to operate the escape hatch and how to use space toilets. In radiation therapy, we have also evolved. We no longer train product or theory, but we focus on what knowledge is needed to accomplish a clinical milestone. For example, do you want to get to VMAT or stereotactic or adaptive? Okay, let's work with you to get you to that clinical milestone as efficiently and effectively as possible, all the time focusing on the clinical milestone. Another area is task-oriented learning, where a learner only focuses on the tasks they will be conducting, remembering that the roles and responsibilities often change in different countries, or even between institutions within the same country. Task-oriented learning means that learners focus only on what they need to know, enabling them to get to the actual treatments faster. Moving on to the second principle, recalibrate how knowledge is shared. Firstly, we need to recognize that we often assume that training is how we gain knowledge, and it is, but it's not the only way, and it isn't the, excuse me, it certainly isn't the predominant way that we receive information these days. We all received information about this webinar, for example, but it didn't come via training. Information and knowledge is all around us, and we can get it in many different ways. So it's important to optimize the flow of information to people learning about radiation therapy. Parallel to this is when we receive information. It's commonplace to reach into your pocket, grab your phone and Google something, right? Information at your fingertips when you need it. Finally, and especially true for COVID times, we've seen an explosion in learning technology options. Zoom is a household name. Microsoft Teams, barely heard of just 2 years ago, is now as ubiquitous as Microsoft Word. A good example of technology, excuse me, a good example of learning technology is mechanical simulators being replaced by virtual reality simulators in the space industry. But we haven't been left behind in radiation therapy. In fact, we've made some really cool advances. We've gamified treatment planning training where learners can compare plans with peers all around the world and see how they did, take on-demand video classes from the featured experts so that they can improve, all the while having fun while competing on a scoreboard for recognition. Technologies such as DAP or the digital adoption platforms are increasingly popular in our medical field. You've probably used a DA before, where you go to a website and it guides you through a series of clicks to perform a specific task, like an online integrated guide, giving you the knowledge when you need it. HoloLens training has allowed highly tactile training that we had previously thought had to be done in person, like brachyapplicators, to be conducted when trainers couldn't travel due to COVID restrictions. And finally, partnerships with our radiation therapy community provides constant knowledge transfer by remote coaching, mentorship, and residency, allowing expert guidance for prolonged periods of time. So moving on to number 3, it's a unique thought point because it serves as a reminder that we constantly need to stay in sync with the technology, something that Steve mentioned in his talk. As product simplicity increases, the knowledge required to operate the product decreases. So it's imperative that we continually assess what knowledge is needed and how we get that knowledge. If we don't, we might be focusing valuable time on providing knowledge that is no longer necessary, or worse, not providing enough knowledge to be able to use the product. As long as we maintain the appropriate knowledge for the level of product simplicity, we can maintain utility and accessibility. Now, that's not to say that the knowledge requirements will become zero. To be human is to be curious and to grow knowledge. So we should be creating a low boundary for entry and access to the best radiation therapy so that clinicians can focus their capabilities in other areas, such as spending more time with patients or focusing on the next advancement in our field. But we should be aware at all times that what's an appropriate level of knowledge today may not be an appropriate level of knowledge tomorrow. And with that, excuse me. With that, I hope you find these thought points interesting and thought-provoking. I want to say thank you again to GCR, but more importantly to all of you guys attending. We can learn a lot from spaceflight, but it did take us 60 years to make this happen. We don't have that time. We need to help patients all over the world today. So it does take a village to kind of execute on this. So I want to say thank you to all of the attendees, because if you're on this call, you are part of that radiation therapy village. We really appreciate your time and thank you, everybody. Over to you, Pat.
Great, Paul, that was great. That's lovely. Thank you so much. I thought this was really thought-provoking, and people, thank you for your comments. And Yakov, I think very good point there about saying mentoring is important. Now, it strikes me that we've got to take a step back now and think, what are we doing? Rather than, as Steve said, just go along the same track, doing the same things, we'll get the same result. We don't have time. We've got to think differently, and we can do that. So can I first open it up? What do people think the barriers are? Don't know if, Darren, we can see everybody on the screen. I can only see myself. Yes. Who am I going to point to? Perhaps Steve, while people are gathering their thoughts, what do you think the barriers are to all this? Why are we not? Is it because clinicians are really diehard, I can remember how to hand plan all this fancy new stuff? Or is it we don't have the power and control? Or is it we haven't had that mindset change? Or we haven't been forced to, as you say, we all had to use Teams and everything in COVID. We just got on with it. And like the mobile phone arrived, we just got on with it. So where do you think the barriers are?
I think there are probably a number of barriers. So I think it's not just the one, and I think if there was one, it would probably be pretty straightforward to solve. So I think it's multidimensional. So I think there is definitely a let me start with one that would be a financial barrier. So I think the way radiotherapy is procured is an interesting thought. Mostly radiotherapy tends to be bought through capital budgets, and we're really good at securing money to buy Linacs. We're less good at securing financing for more of the OPEX driven elements. So whether it be training, whether it be software, whether it be making sure that technology is kept up to date over the life of the equipment. But it tends to be that in many countries, there's a chunk of money available at a point in time. Everybody scrambles to buy a load of new machines, and then it's like, well, yeah, but how are we going to operate this? How are we going to make sure, onto the second point, that the clinical skills that are evolving as technology evolves and then kept up to date over that period of time? So, as new machines come onto the market and allow new, techniques to be possible, adaptive would be one example of that. How are we going to make sure that we have the appropriate budgets to make sure we constantly increase the clinical skills in parallel with the technology that's available. Technology adoption is a close parallel with that. I hate to compare a Linac to Office 365. That's an awful comparison. But if you think of what you can do with Microsoft Excel and what you could actually do with Microsoft Excel if you were a fully qualified Excel user, you're probably using 5% of the capability within most of your Office tools. And I guess my challenge would be, that's another barrier with our technology, is making sure that we give people the adequate support. And I love the mentoring idea, because actually, if we could use technology to release time to focus on those other tasks, that would be one solution, right? So if we can, for example, say to doctors, rather than spending 3 hours contouring this head and neck with a mouse, great fun, thank you very much. You can now do that in 15 minutes or 20 minutes. And the other 2.5 hours you've now saved, you could spend mentoring or training other people. Would that be a good use of your time? Right. So that would be one concrete idea. The other one would be patient access. Sorry, I'm rambling away here. So, people who are in remote and distant locations, as an IT guy, I'm going to get killed by all my Varian colleagues. Today, a Linac is essentially a really fancy printer at the end of a network. Could we be smarter about how we connect our Linacs across broader networks, so that people who are out there in the community who cannot travel hundreds of miles every day to get the radiotherapy could get high quality treatment at the end of a sophisticated IT network? I will pause because I could keep going.
No, that's great. Perhaps I could, Mary Gasparovich, you're on, aren't you? Perhaps could we have some thoughts from your experience, having started this in 2015, about what we should be doing? How far have we come, and how can we quickly get a little bit different with our technology?
Well, I think one big lesson. Hi. It was, first of all, a wonderful presentation, very, very, very needed to sort of change the mindset of how we think about things. One big lesson from the Global Task Force and the Commission was that these numbers that we put forward were so large that in a nanosecond you think, we have to change the way you're doing the business. There's no way that you can have the same staffing standards, the same length of training, because you'll never close the gap. So, I fully agree that, and we started in Canada, the competency-based training, where you need to know what you need to know to practice, and you don't need to know everything. It started actually in orthopedics, where they decided that an orthopedic surgeon who has to fix fractures doesn't actually need to know the intricacies of management of rare sarcomas. Maybe, that's the next stage of subspecialization, but you need to produce the orthopods to fix broken ankles during the winter and stuff, and maybe they need different training. And the same for radiation oncology. Does everybody need to be proficient in everything, or can we shorten the training period and have sort of graduated licenses the way you do in driving the car. You have a graduated license, you start driving, and then you can drive alone, and you can drive on the highway, and there's different stages. The other big thing is task shifting. You know, I've been around the block for many decades, and what I did as an intern, it's now not only the nurse but technician does. Physician doesn't do that anymore. We've moved on, and you know, can you give up this fascination of radiation oncologists that has to be on the treatment unit because it's necessary? I would think it's not necessary. We have very competent radiation technologists that can handle everything, and you can move physician up to see more patients rather than stand by the machine and make sure that what's obvious is being delivered. So I think we need to change the mindset of how we train, how we deliver care, who does what. Do we need more professions? And then change the staffing standards. And also, we already changed fractionation. You know, running a big radiation department, you're very, very conscious of the fact that, let's say, 30% of your workload is breast cancer. And if somebody tomorrow finds a biomarker that will tell you who needs post-op breast radiation and who doesn't, because if you don't have radiotherapy post lumpectomy, the recurrence rate is not 100%, it's 20 or 30. If you can identify the 70% of patients that don't need it, suddenly your workload drastically shifts. And we've seen the shift in workload with fractionation. If you change the breast treatment from, you know, 16 or 20 fractions to 5, suddenly you have totally different needs for equipment. So the future challenge is change the mindset of how we operate, how we interact with technology, give up some of these sort of fixed ideas, but also have much more nimble system of adjusting the requirements for equipment and staffing depending on the workload. And people are very reluctant to do that because they worry about a loss of resources. But I think you can shift those resources to innovation, to you know, adoption of new technologies, which everybody's struggling with. So having a much more nimble approach to implementation of radiotherapy, I think, would be good. I'll stop here, but thanks for asking me to comment.
No, Mary, that is just absolutely fantastic and actually spot on. That's great. So some other experience we got. Yakov, nice to meet you. You've been in the chat. Tell us your thinking.
Thanks. I mean, these are very insightful observations. And having been involved in radiation therapy for about 40 years now, and also involved in some of helping colleagues in low middle income countries in totally different settings, Africa, Latin America, and so on. Situations are very, very different. And we sometimes encounter that technology by itself, without the infrastructure, I mean, it's really not working. I've seen, you know, machines worth, you know, close to $1 million in a place that cannot afford, and not having spare parts or not having service available because, I mean, they didn't figure it out in the budgets, or the administration was totally not aware that, I mean, you know, maintaining the equipment is so important. Mary's observation about being nimble, I mean, in terms of what we do in the clinic, I mean, that's absolutely true. Hypofractionation is a great example of that. And the thing that I face very often is that the people in the field that they try to modernize what they do in their clinic, whether by introducing new equipment or new technology or new techniques, are faced with a tremendous amount of difficulties. I mean, and they don't have the time to get the experience on their own. I mean, spend 10, 15 times years until you figure things out. And I think that's why Medical Physics for World Benefit has been tremendously focusing on the on the ground assistance, you know, to the extent. And we are a small relatively new organization, and we understand we cannot resolve all those problems. But I mean, trying to combine the efforts of different organizations and manufacturers and vendors and support personnel, I think it's so important in order to bring the people up to speed, because we can. I mean, Mary, I mean, you say to shift the load of the physicians to to technologists and physicists and dosimetrists. I think it's great. I mean, if you have those prepared, I mean, to do that. And just the difficulties even to institute training programs, which we are trying to assist in a couple of locations. It's a very, very difficult thing because of the inertia of the systems. I mean, trying to implement new classes, I mean, at the university level and training, I mean, which is the most important thing, because classroom teaching goes only so far. I mean, if you have to deal with patients, you cannot just take the book and try to read, or even if you have Google on your lab, on your cell phone, that still doesn't cut it.
I think very good points you've made there, and particularly you were saying about combining organisations. I found certainly in the UK trying to sort of manoeuvre, trying to suggest things. There's different disciplines. There's different people organising different things. Even in the government level, there's different people organising different things. So to get everything together is actually part of the problem, and to get somebody to see an oversight. And that it's really, I suppose that's something what the GCR is trying to do, be a broad church for everybody to have this through. And as you were saying, there's different challenges with low and middle income countries, aren't there? No, it was really, really helpful. I just think some other names there, Michelle or Barbara, have you got any thoughts, another information to provide, or your experience or anything there? Or perhaps I can bring in Therese, some sort of, we haven't talked much about evolving technology or remote working. What's your thinking about, again, the sort of barriers and what we need to be thinking laterally about?
Hi, Pat. Hi. You were referring to me, right?
Yes, sorry, yes.
I was just wondering. Well, I think it seems like there are so much solutions out there that could really help up and support both long-term and short-term. But this we're saying, and like Mary also addressed, and Jakob too, that it's, how do we make the change? How do we get that adoption in place? And Steve, you also talked about partnerships. We have to have real partnerships, but how do we get them in place? Because we talk a lot about it, I think, but how do we get it in place, and how do we create this change? And how can we do that on many levels? I mean, now here we're talking on more of a global level and effort, and hopefully that could spill over into or mixed with different markets and countries. But what does it take to have real great collaboration? I think a really important piece of that is trust, of course. And so how do we build trust in between all different actors out there? With, from WHO and IAEA to hospitals to governments and to industry, and have a real, frank and open way of collaborating. I think that's needed in order to get more adoption of radiation therapy to happen.
No, good point. Mary, perhaps in your, sorry to drag you in again, perhaps in your experience of getting that trust and going, at what level, and again, we have to be fairly quick about that, is there anything we should be pushing for in terms of countries implementing radiotherapy, set some standards of interaction? Is it something where, not legislate for, but sort of suggest that this is minimum standards and this is best practice? Or what, in your experience with the UICC and things, what should we do? What are practical things should we be suggesting?
I think we need to train more people in low and middle income countries. We need to open opportunities to train. It's very expensive to send somebody from African country to Canada or UK for training, but if we support them for a piece of this training, they can be trained locally with sort of exchanges to other centers. And if you actually support development of both radiation technology profession and physicists in low and middle countries, in addition to training radiation oncologists, I think eventually, the sort of human resources will improve. I think we need to change the mindset. Instead of thinking how we can go and help in Asia and Africa, is how to really empower development of local workforce. And I think it's huge. Yakov knows that it's very difficult, even in high-income countries in other regions, to get people to understand that you cannot have good radiotherapy without physics. People just don't understand it. They think you buy the machine, you push the button, you just need a doctor and maybe a technologist. They don't understand the crucial role of physics. They don't understand the crucial role of maintaining contact with industry, of having proper maintenance of equipment. If you don't maintain your car, it doesn't last as long. Everybody knows that, but somehow you think you can buy a radiotherapy machine and it'll work for 10 years without any support. So I think changing the mindset, I think, is something that needs to be done quite urgently. As far as adopting competency-based education, learning online, everything that the first speaker were talking about, I think, to a certain extent, you have to just have a just do it attitude without sort of worrying that you're going to step on somebody's toes. That's really what slows us down, is people are so mindful that somebody can get upset about things that it stops progress. Anyway, I'll stop here. But
no, that's good. No, that's great. Yes, and one wonders whether one should be doing more with societies who control these issues, or whether, as you say, just go and do it. Anybody else want to add anything to this bit of the discussion here? Hands up or anything? What I just wanted to touch on before we close now is about getting nearer to industry and getting that partnership going with industry. How and perhaps I should turn to our industry colleagues on here, because I think in a sort of vendor neutral way, how can we partnership better so that we're integrated? Because I suppose we partnership with Microsoft easily, you just get on with it, there's no issue. What's the barrier there with industry? And from your angle, are we being a little bit picky, or what's the issue? Who would like to sort of speak to that from industry?
I'm happy to, Pat. Good afternoon, I'm Michelle Cook. I'm from Varian. Can you hear me okay?
Oh yeah, Michelle, great. Do speak. Yes, tell me. What's your thinking?
Yeah, I mean, I think I've been in the world of radiation therapy my entire life, trained in the clinic, and now work for industry. And I think partnering. I mean, when I left the clinic and then went to the dark side, it's kind of like why have you done that? But it really is, for us, we're all in this together, right? The industry and the clinics treating the patients, and you're doing the best that we can. And I think in terms of partnering with industry, and I was very intrigued to listen about resources. We talk about resources in machine, it's also resources in people, and as we've heard as well in the low middle income countries and everywhere, getting people interested in careers in radiation therapy and medical physics. I guess many of us have been at family, friends, or parties, or wherever, and you say, "What do you do?" And you work. I work in radiation therapy, or when I used to be a medical physicist in radiation therapy, it's like, what's that? So the visibility about the careers and getting graduates coming through, working in the hospitals, or working through the industry is one way that we can really improve the resources, the capital resources, the human resources that go into this. Because we see in many countries, people don't go into this. They go to be doctors or lawyers or other industries that they see. It's getting that visibility around this particular side of the medical profession and the work that goes into keep treating cancer patients. So that's my.
No, good. And I must say, certainly hearing Paul talking about the gaming, I would have thought we could have collected quite a few whizzy kids along that line, and perhaps we should be doing it that way. No, good point. And I see, is it Young? You've just put something in the chat box about our training strategies. Did you want to sort of say something about that? Where are you?
Yeah, I'm right here.
Hi.
Yeah, no, I think it's the speakers alluded to it, and I think it's alignment that's really difficult to have. I think we have so many different organizations, so many different people working towards something, but I don't think everyone's really aligned. And I think it's trying to figure out how do we get together. Obviously, there's at least 2 companies represented here. I work for Elekta. And then we also have a lot of people with clinical backgrounds. So I have a clinical background in medical physics. I only moved into industry last year. When we have all of this knowledge, however, everybody has a different view, a slightly different view, and who needs what. And also, what is that sort of the minimum thing that we need to have, alignment that we need to have, and everybody works towards it, that we can actually then move something, and that move that iceberg rather than work towards sort of that tip of the iceberg, just chopping at it. And so, is it something? And then this is just a thought. I think Paul mentioned it, and so did Steve. We talk about training, but I don't know if we see it as a sort of a global way of training as a whole. And this reevaluation of what is needed that matches up to the particular technology that we're delivering. And how do we do that well? How do we do it so that everybody's aligned? I think that's sort of, my quick thoughts. How do we get everybody to actually work towards exactly kind of that minimum barrier that we want to hit?
No, thank you for thoughts. Well, I suppose one way is to name it, that needs to be done. So hopefully, with the white paper we produced for this, is talking about some things that need to be named and need to be said, and that's one of them. I just think anybody else from industry or non-industry, I just wonder if I could bring in Birgit, because you have been in not one of the main industry players at the moment, but others, and a lot of other experience at a global level. What's your thinking about getting this partnership with sort of industry and clinicians and this multiple bringing people together? What's your thinking, Birgit, if you're there?
Yes, I am. Thanks, Pat.
Oh, yeah, hi.
Yeah, very good point. I think we've talked about partnerships repeatedly, and I mean, Mary, you've led the charge at the time you were with UICC and with the Global Task Force and others as well. But I think there's always an opportunity, and the Global Coalition is in fact an example of this, of working together to raise awareness, whether it's on the training, picking specific priority initiatives that we can pursue together to raise the awareness and what's possible with radiation therapy. And the pharma industry does this very well. The diagnostics industry does this very well, both in vitro and on the imaging side. And we should continue to take lessons from their playbooks, because that's the most effective way to work together. And I think, again, the Global Coalition and this team is a prime example. It doesn't mean we're not competing on the ground, so to speak, right? We're selling our systems on the ground, but at this level, at a policy level, bringing people together to discuss where we can focus our efforts, to advocate, to make sure people understand, as was mentioned, by both speakers, how do we raise understanding about what's important? Can we set standards for education? Can you put in place, just to take a page from normal education, you have the International Baccalaureate, which took, decades to put in place. But that was saying, the way you learn in Germany and the way you learn in the US and the way you learn in the Philippines, there ought to be a standardized curriculum that we can all align to. let's look at how the educational systems do this, real education on the ground. And are there things we can learn there? And groups like this can partner to make that happen. I think there's a lot of opportunity there. We have to keep plugging at it.
Yeah, no, thanks, Fergie. And I think very good thoughts there about learning from others. I'm conscious when we talk to our diagnostic colleagues as well, they've always said, get together at the top, push the policy, or say, okay, street fight at the bottom if you like about who's getting what, but the top there, be absolutely together with a one message. And I think we need to, as a radiotherapy community, to be there with our one message, and then all things can come. And it's not just industry and clinicians, it's the different parts, physics, radiography, and therapy, all these things. I think that's really, really important. Well, look, I want to bring this to a close, and I've just seen Therese very interesting comments in the comments box we've got and about Europe and our different ways. But look, we want to come out of this a white paper to actually get this conversation. Where are we at in this conversation now? Where are we now, and where do we want to get to? So we will draft something and involve you all here, and so we can get that out to hopefully get that conversation going. And then hopefully you'll all contribute to that and get something done, which is really exciting. So Darian, perhaps if you could bring up the final thing, just to mention a few things, is that, so we'll move on with the white paper, just to say we've got a YouTube now, so this video will be uploaded on this. So in fact, do share it with everybody, get this conversation and spread the word about this. And, you know, other people we need to invite into the GCR, you know, you'll know these people, do everything like that. It's really, really important. Darian, who's been there, is our new communications director. You know how to get in touch with us there. And obviously feedback we need. Also to announce that we have set up our new website. So please do go and visit that as well. And very importantly, as we discussed last time, our advocacy toolkit is linked very much into this. That will be going through now to be released. So hopefully that will be on the website, and we'll tell you more about that. And apart from that, really, I think spread the word, and we've got our Twitter feed. And apart from that, I'd just like to thank our speakers and thank all of you for coming. This was really, really, really great session, but it's the start of something. And I think as a community, we need to be getting on with this. So many thanks indeed. And hopefully our next webinar will be in a month or so, and we'll see you all again then.